We are starting a new topic today, and I have prepared for you a video. Okay, we will watch a video, and while you are watching a video, you have to answer some questions. In fact, you will do it after the video. I will give you these questions, and I will ask you now to read these questions in pairs. And if you have some maybe some words that you cannot understand, that's difficult for you, you can ask it before watching the video. So
1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. With just these 10 symbols, we can write any rational number imaginable. But why these particular symbols? Why 10 of them? And why do we arrange them the way we do? Numbers have been a fact of life throughout recorded history. Early humans likely counted animals in a flock or members in a tribe using body parts or tally marks. But as the complexity of life increased, along with the number of things to count, these methods were no longer sufficient. So why did the Hindu-Arabic system, along with so many others, use base 10? The most likely answer is the simplest. That also explains why the Aztecs used a base 20, or vigesimal system. But other bases are possible too. Babylonian numerals were sexagesimal, or base 60, and many people think that a base 12, or duodecimal system, would be a good idea. Like 60, 12 is a highly composite number that can be divided by 2, 3, 4, and 6, making it much better for representing common fractions. In fact, both systems appear in our everyday lives, from how we measure degrees and time to common measurements like a dozen or a gross. And of course, the base 2, or binary system, is used in all of our digital devices, though programmers also use base 8 and base 16 for more compact notation. So the next time you use a large number, think of the massive quantity captured in just these few symbols, and see if you can come up with a different way to represent it.
okay, so we watched the video. What was it generally? What was it about?
About numbers.
About numbers, yes.
About their history.
About history, numbers history.
How they count different things.
How they count different things, yes. So you have some questions. I think 2 minutes enough to discuss and answer these questions. Discuss. If you have some difficulties, you can ask me. Are you ready to answer? Yes, let's start. So your first question was, what did different civilizations use to record larger quantities? So how do you think? Which one? Body parts and tally marks. For example, they used tally marks to represent some quantity, right? Like that. Okay, nice. So what about the second question? What innovation did the Roman numerals use? What was the innovation?
Depending on their position.
They had new symbols for bigger numbers, like CM. Okay. What else?
Depending on their position.
Loudly, please.
Depending on their position.
Ah, yes. Depending on their position, numerals could be added or subtracted. Like, for example, if I will write two different numerals, Roman numerals, what is the difference between these two numbers?
+1, -1.
In the first case,
-1.
what minus 1?
5.
It is 5 minus 1 because 1 is at the left side, and here it is 5 plus 1. So because of it's at the right side. So this was the innovation of Roman numerals, right? Okay. And we are learning with you different numbering systems Today we will talk about binary numbering system. So what is numbering system in fact? We said that people used telemarks to write a quantity, and we can represent this quantity by different symbols. Count please, how many telemarks here? How many telemarks I wrote? 13. And how we are writing it in our daily life? 13? 1 and 3. Why you are writing here 1 and 3? What does it mean?
Because base is 1.
Base is not 1.
10.
10. Base is 10. So it is 1 multiplied by 10 plus 3. Right? But we can write it in different way. For example, if there is base is 5. If base is 5, you will count it like that. So here one group of 5, then the second group of 5 and 3, right? So we have here 2 groups of 5. And in 5-based numbering system, how you will write it? 2 groups of 5, so it is 2 plus 3, right? So it is the representation of 13 in 5-based numbering system. It's difficult to understand, right? Because we are using decimal numbering system, and I think that, did you know that there was some other numbering systems before this lesson? But there is so many numbering systems. So in decimal numbering system, we're using 10 different symbols, right? And the base is 10. In binary numbering system, there is only 2 different symbols, 0 and 1. That's all. Okay? So, for example, when you are writing 8 in decimal, it is 1, 0, 0, 0 in binary numbering system. Okay? So, how to convert? For example, I know I have a 13. How to convert 13 to binary numbering system? There must be some what? Some rule, right? Let me show you a rule. So converting decimal number to binary. While we are converting, as example, I took 53. It's an example. So look, please, how we will convert it. We are taking a decimal number, 53, and we are starting it. We are starting to what? To what? To divide it by the base, by the 2. And then we are fixing integer remainders. What will be the answer when you are dividing 52 by 2? Yes, 26. 26 when we are dividing, then we are continue to divide it. 26 we are dividing by 2 again. And what is the answer? 13, right? And remainder is 0. So then 13 is divided by 2 again. 6. The answer, remainder is 1. Then, so let's try to divide 13. Let's do it together. We have 13. Let's try to convert it to binary. So what we are doing? Divided by 2. And what is the next? Remainder is 1. Answer 6. By 2 again. 0. 3. Then 1. We are dividing by 2. And answer is 1. And what is the next? We are fixing all these remainders, and we are writing them starting from the end. So the answer, so 13 in decimal, it is what? 1, 0, 1 in binary, right? Did you understand how to do it?
Yes.
Okay. I prepared for you a rebus. Okay. What we will do? So, you will work in the pairs, and here each group will have numbers. You will convert numbers to binary numbering system and find find a letter that is recognized by this number. For example, you are finding 24, you are converting it into binary. For example, it is 1001, for example, I don't know. So 1001, it is E, and you are writing the letters. At the end, each group will have 4 different letters, and each group has its own number. At the end, we will connect all these letters, and we will get very important proverb. Okay? So let's go finished? Okay. Please write your letters under the group name. Who else? Okay. Okay. We are coming to the end. So can you read the... Okay. So let's read together. Be what? Be patient. Good things. Yes, be patient. Good things take time. Okay, nice. Was it difficult to convert?
No.
No. So we'll learn today how to convert decimal number to binary, right? To represent it in different way. So I think we will learn later how to convert it back from binary to decimal, but it's not today. So your homework will be try to convert these very big numbers to binary. How do you think? How many digits you will have? 10? 10, 11? Yes, it will be a very big number in binary numbering system.